Hello, everyone. Give me just a moment. I have some technical difficulties. All right. Everyone should be able to hear me at this point. Sorry for the delay. Of course, this technology, man, can be kind of challenging at times. So, um, because my tablet didn't want to work right, we are going to do this the old-fashioned way, the quote-unquote old-fashioned way. Pencil and paper. So get this squared away. We'll bring up the study guide and we'll go ahead and dive right in. If you have any questions, definitely feel free to go ahead and ask those. You sure we're good? Yeah, I'm good. You go ahead and ask those. Me just kind of droning on is not. That's not fun. Preview. There it is. All right. So I will go ahead and just get started, but you can ask questions as you see fit. All right. So first question. Make sure y'all can see. Yep, y'all can see that. That's good. All right. So we have a triangle. And this is from one version of the study guide. You may have different numbers, but it'll be the same type problems. That's theta. This is 15. This is 8. Go ahead and get calculator out that I can use when we need it. All right, so they ask in this question, they ask for cosine of theta, tangent of theta, and cosecant of theta. The first thing that you want to do when you have when you have a triangle is you want to get all 4 sides of it. Oh, wait a minute. We didn't have one page of formula notes using the last test, or did you misunderstand? No, you did not misunderstand. You did not misunderstand. One formula sheet, a notebook paper or printer paper, standard size, front and back, whatever you want on it. And I know that the syllabus says, show it to me. So, I guess you should definitely do that, but you can put whatever you want on it. Like, that doesn't really bother me very much. Can I go over coterminal and reference angles? Yes. I'm going to try not to forget that if I do remind me. But I'm going to try not to forget that. So let's keep going. So what we want to do is we want to find the hypotenuse. From this angle, this side, I wish I had different colors. This side is the opposite. I didn't use them. This side is the adjacent side, and that side is the hypotenuse. The hypotenuse is always across from the right angle. And it's also coincidentally the longer side. So we use the Pythagorean theorem to find it. So if we say, we'll just say a squared plus b squared is equal to c squared. So 8 squared plus 15 squared is equal to c squared. The hypotenuse is normally c. All right, so that's 64 plus 15 squared is 225. So 225 plus 64 is equal to 289 is equal to c squared. Square root of both sides, and you can do this in your calculator. Unless you are familiar with Pythagorean triples, then you get 17 is equal to c. We're only taking the positive one because it's positive. So this is 17. Now that we have all of the sides, cosecant of theta is equal to adjacent over hypotenuse, which the adjacent is 8 and the hypotenuse is 17. So that's cosine. Tangent is opposite over adjacent. The opposite side is 15. The adjacent side is 8. And the cosecant is, if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. 17 over 15. And that's the answer to that question. Well, let's get it. Oh, I'm moving this too fast. I hope that you have it. Okay, I didn't use it on the last test. It definitely hurt. And yeah, definitely, you want to make sure that you have that. I mean, hopefully you go through enough homework to where it won't be too necessary. But either way, we know now, so we can go forward. All right. So suppose theta is an angle in standard position. Let me write this problem down. Hopefully, theta is an angle in standard position whose terminal side intersects the unit circle at 3 over 5, negative 4 over 5. All right, and they want us to find cosecant of theta, sine of theta, and tangent of theta. That's on the unit circle. So we kind of already know what sine and cosecant is, but I'll be thorough. If you're curious, I can show you. Oh, just join. Also, someone asked about a formula sheet. Are we allowed to have that during the test? Yes, we are. So first, we need to draw a triangle. I probably shouldn't draw it right there because that's where my answers are going to go. So let's do it over here. All right. 3 over 5, negative 4 over 5. So we are in quadrant. 3 over 5, negative 4 over 5. That is my point in the unit circle. So let's just say it's right there. Because positive x, negative y. This is quadrant 4. So if I draw a triangle out of that, and again, it's in the unit circle. Then we know that the hypotenuse is 1. The x value is 3 over 5. And the y value is negative 4 over 5. We know that because that's the point. 3 over 5, negative 4 over 5. Okay, so the sine value is, you have to see that. Sine value is 4 over 5. We don't even have to do anything with that. And the cosecant is negative 5 over 4 because it is the reciprocal of the sine value. Tangent is y over x, which if you look at this triangle, okay, it'll be right there. Opposite is y, adjacent is x, and it's always that. Right now, y value is negative 4 over 5, and my x value is 3 over 5. Make sure y'all can see that. I think you can. Okay, a couple of different ways to do this. the easiest way, -4, this is -4/5 divided by 3/5, which is the same as -4/5 times 5/3. Because keep, change, or keep, change, flip. I don't know if you remember or heard anything about that, but that's what we do. Fives cancel and it becomes -4/3. Let's see. This is kind of the same thing. Drawing pictures, and you should draw a picture whenever you're given theta, and you have to find all the different values. That's drawing triangles. I'm trying to find a coterminal angle problem. Madison, if you can think of one, then if you see a problem on the study guide that has that, then let me know. That'll help. What's that word? Focus our search a little bit. Let's go into. All right, let me just go here. Just study guide, content. I'm looking for a coterminal angle problem. Okay, here we go. This will be our third problem. Make sure y'all can see that. There we go. All right, find an angle between 0 and 360. So 0 less than theta is less than or equal to 360 degrees. That is coterminal with negative 330 degrees. All right, and the second one is 0 less than or equal to theta is less than or equal to 2 pi, which means this is in radians. That's coterminal with 7 pi over 3. All right, so we'll label this A and B. So for A, coterminal means co means together, terminal means ends. So it's two angles that end together. All right, these angles are separated by a series of rotations. So whatever theta is, coterminal is whatever theta is theta plus or minus, we can say 360 degrees times r, where r is the number of rotations. That's really math looking. So basically, you add or subtract multiples of 360. They want us to find something that's between 0 and 360. Negative 330 is less than 360. So we're going to take negative 330 degrees and we're going to add 360 degrees. And we're going to keep doing that until we find out an angle in this range. Doing this, we quickly see that it is 30 degrees. So that is our answer. All right. Also, if you are familiar with positive and negative rotations, then you know that negative 330 degrees is in the same position as 30 degrees. For B, radians is a little different. All right, we know that 7 pi over 3 is the same thing. Fractions tend to make people a little nervous, though. So we know 7 pi over 3 is greater than 6 pi over 3, which is 2 pi. So we're going to subtract 6 pi over 3 until we get between 0 and 2 pi. So 7 pi over 3 minus 6 pi over 3. We pick that because 6 pi over 3 is the same, reduces to 2 pi. So we're subtracting a full rotation. That's why we did this. These two problems are the same thing. You're adding and subtracting 4 rotations until you get within a range that you want. So if I subtract that, I end up with pi over 3, which is definitely in that range that we want. All right. I don't know how helpful that was. Definitely give me some feedback. Thank you. Here's the reference angle problem. Reference angle of negative 19 pi over 12. Okay. Negative 19 pi over 12. So this is less than 0. So we're going to add a full rotation. A full rotation is 24 pi over 12 because this reduces to 2 pi. That's why I picked 24 pi over 12. Right? Whatever the denominator is, I multiply whatever that denominator is by 2 and slap a pi on it. That's a full rotation. So negative 19 plus 24 is 5 pi over 12. And that's my answer. Something to remember. Reference angles are always acute. They are always in quadrant 1. So they're always between 0 and pi over 2. Oh, you're welcome. Okay, let's go back to, I mixed up the problems, but let's go back to, that's the same thing we just did. That's the same thing we just did. Yeah. The same thing. That's all right. So whenever we're talking about arc length, this is problem number 4. The formula for arc length is S is equal to R times theta, where theta is in radians. So if it is not in radians, you have to convert it to radians. All right. So in this case, the arc length is equal to 21 meters, and the theta is equal to 67 degrees. So first thing we have to do is we have to change 67 degrees to radians. So that is, I'm going to multiply 67 times pi over 180. So in your calculator, when you do that, take away the pi, just do 67 over 180, and see if you end up with, if it reduces, which it does not. So the radian form is just 67 pi over 180. So we're trying to, in this case, we have the S and we have the theta. We're trying to find the R. So what we do is we divide both sides by theta, and I get S over theta is equal to the radius, which is what they want. So in this case, S is equal to 21, and we're dividing by 67 pi over 180. Now, believe it or not, If you use your calculator correctly, you can put this in your calculator, just like this. All right. Even with the recommended calculator, you can just put it in there. So let's do that. Oh, here it is. So I put 21, and then on the bottom I put 67 pi over 180. Right. I put it in there just like that because they said round to the nearest tenth. So put it in, and R is equal to 17.958, so on and so forth, but rounding to the nearest tenth is the 10th place. This is 5 or greater. So it increases that. So this becomes 18. So that is an arc length problem. Okay, let's find another one here. Sorry, hold on. It becomes all right. All right, so all right. So now we're going to do co-function identities. We're going to do a co-function identity problem. Y'all can still see that. All right, so what we're given is the secant of 5 pi over 12. And they want the co-function ID, co-function, an expression equal to this, equal to something. Okay, the co-function is, if you think about it, it's kind of the opposite trig function. So like sine and cosine go together, tangent and cotangent go together, secant and cosecant go together. Okay. What this really is, this is really looking at a triangle and looking at the two angles. We know that the two angles have to equal 90 degrees. Like in a triangle, we have a right triangle. We'll call this alpha. We'll call it beta. Alpha and beta have to, okay, yeah. Alpha and beta have to equal 90 degrees. Or if we're in radians, alpha and beta have to equal pi over 2. Because pi over 2 is the same thing as 90 degrees. Okay. So 5 pi over 2 plus, no, 5 pi over 12 plus something is equal to pi over 2, which is 6 pi over 12. Or that becomes pi over 12. So in other words, the secant of this guy is the same thing as the cosecant of that guy. If we were doing this in regular angles, that's like the sine of 30 degrees is equal to the cosine of 60 degrees. 30 plus 60 is equal to 90. The sine of one angle is equal to the cosine of the other angle. All right, that's really helpful. It is helpful to understand how the two things relate to each other. Let's see what else we got here. All right, this is a word problem, but this is really similar to what we've been doing already. With word problems tend to be. All right, so let's draw this. Draw a ramp. There's a platform. Wow. This is the ground. All right. This is 20. This is X. This is 11. All right. Platform. Wow. It's a pretty good drawing. Anywho, around 20 feet long rises to a platform. The bottom of the platform is 11 feet from the ramp. Find X, the angle of elevation of the ramp, round your answer to the nearest tenth of a degree. So this is the angle that we're using. That's bad. Okay. This is the angle that we're trying to find. This side of a right triangle, this side is the adjacent side. This 20 is the hypotenuse. So the function that we're going to be using is adjacent over hypotenuse is cosine. So the cosine of X is equal to 11 over 20. So that means that X is equal to the arc cosine of 11 over 20. And that becomes 56 point, round to the nearest tenth, 6 degrees. This is a calculator problem solely. You're not going to be calculating arc sine, arc cosine, any arc anything without your calculator. Okay, easy. But we need to use a calculator other than the TI-30 X2S for trig functions on test 2. I thought I came because some problems to the guy that required a graphic calculator. No. Okay. Let me address this. 7 people watching. Other people will watch later on. The math department issued guidance that the only in the before calculus sequence, which is college algebra, pre-calculus, I think it's called applied calculus math. I think it's 1190 or 1160 or something like that. All the before calculus classes are only allowed to use the TI 30 X2S. Okay, anything else, you use your Alex calculator or you do it by hand. That is the math, that's the departmental guidance. So it's on the syllabus, but it supersedes me. That was not, it's not what I decided, it's what they told me that that's what they wanted to happen. All right, so any any pushback you get from me from your calculator, and on your testing video, you should show your calculator that you're using. Any pushback you get from me, uh, I'm enforcing something that I was asked to enforce, and I'm going to leave that at that. All right, so tell whether for each function below, indicate whether it is odd, even, or neither. So this is number 7. All right, so f of x is equal to secant x. We know that cosine is even, so secant is even. G of x is equal to cosecant of x. We know that sine is odd, so cosecant is odd. Okay, I think it might be on this phone. Oh, so knowing this, secant of negative 162 degrees, because secant is even, it is equal to the secant of regular 162 degrees. Similarly, cosecant of negative 6 pi over 7 is equal to negative cosecant of, well, I don't need to put a parenthesis there. 6 pi over 7. Even means whether you're rotating positively or negatively, the cosine or the secant value stay the same, which is true. Odd means that if I take the negative cosecant of negative this angle or sine of negative this angle, it's the same thing as doing a positive rotation, and then you just put a negative in front. It's the same thing we just did. All right, this is something I probably should mention to you. Number 8, I have y is equal to 1/2 sine of x. Okay, I'm not going to graph it here for you. I'm going to show you some things about it. Your amplitude is 1/2. Your b value, which this is of the form y is equal to a sine of bx plus c. This is kind of the general form of a sine or cosine or whatever function. B affects your phase shift. B in this case is 1. So it doesn't affect your period at all. And C is your vertical shift, and that's 0. Okay, so when you're graphing it, it's 1/2. So normally, if that's the origin, and this is 1, and this is -1, 1/2 x power 2 pi. You plan on graphing this, but whatever. Sine of 0 is 0. This is power 2. Sine of pi over 2 is equal to 1, but it only goes up to 1/2. Sine of pi is 0. Sine of this is 3 pi over 2 is -1/2. It's normally -1, but amplitude is 1/2. And then sine of 2 pi is 0. So again, I'm trying to scale. Hint. Whenever you're graphing a function, the first thing you do is you find the period. And then you divide the period into 4 places. Those 4 places will be your maximum, minimum, and 0 values, depending on what your function is. And again, this is mostly for sine and cosine. We know tangent is a little bit different. 14, more graphing. 15. Okay. This is number 9. Y is equal to -3 cosine of 5x. They want us to find the period and amplitude with exact values. So your period, which is your b value, well, it uses your b value. So let's do it like this. B is equal to 5, so your period is equal to 2 pi over b, which is 2 pi over 5. Your amplitude is -3. Well, actually, the amplitude is 3. We generally don't put the negative in there because the negative just tells us that we're flipping it, that we're doing a reflection across the x-axis. Okay, but I don't know. It just kind of depends on on how it's being taught to you. Right, let's see what else we got here. We've kind of done this already, but I'll do another one just. Oh, wow. I'll do another one just to kind of be thorough. So we have the point, this is 10. We have the point negative root 7. That ain't a 7. Negative root 7, comma, negative 3. Which that means that we're in quadrant 3, by the way. That helps us. All right, so the terminal side of theta. We're finding values. So draw a graph. This will be right here somewhere. Negative root 7, negative 3. All right, so this theta, right, that's theta right there. So first thing we find is a hypotenuse. So negative root 7 squared plus negative 3 squared is equal to c squared. Should be r squared. Let's just make it a 1. That's your hypotenuse. So the negative becomes a positive. So this becomes 7 plus negative 3. Any number squared becomes positive. Negative 3 squared becomes 9 is equal to r squared. This is 16 is equal to r squared. Square root of both sides. So 4 becomes r. So we have been asked to find cosine of theta is equal to adjacent over hypotenuse, which is negative root 7 over 4. Secant of theta is equal to hypotenuse over adjacent, which is 4 over negative root 7, which we have to rationalize becomes negative 4 root 7 over 7. And cotangent of theta is equal to adjacent over opposite, which is adjacent negative root 7 over opposite, negative 3, which is positive root 7 over positive 3. All right, for this secant, we have to rationalize our denominator. You need to ask me about that if you have questions about it. Let's continue. All right, if you have any questions, definitely feel free to jump in. My goal for this is to answer questions, not necessarily just to randomly do problems. Yeah, that's what it is. 10, so 11. Oh, this is a good one. Cosmo High School problem. So, 2 problems. So for A, so sine of theta is less than 0. Cosine of theta is less than 0. What quadrant is that in? Less than 0 means negative. Hold on. Think of it as okay, let's do because remembering the domains and ranges of these trait functions. I'll write them down. Write them down, but all on your formula sheet, but also think about, okay, one of the reasons that I like trait, and one of the things that has helped me is that there's a symmetry to it. Think about, picture what the function looks like. You know that sine and cosine kind of act the same. Secant and cosecant act the same. Tangent and cotangent act the same. Domains of cofunctions are the same. So sine and cosine, the domains are both negative infinity to infinity. The ranges are both negative 1 to 1. Okay. So they go together. So when you find them, you kind of have an idea of what it looks, of what you're looking at. You graph it either on a graphic calculator or online, or look it up and see what it looks like. You see that the graphs kind of look the same. They just kind of out of phase with each other. The exception being, well, they don't overlap. They're like shifted away from each other. The exception is tangent and cotangent. Those always act in one function. But the domains and ranges go together. Think about what your graphs look like. All right, less than 0, less than 0. That means they're negative. Y value, sine is negative. That's the y value is negative. X value is negative. This is in quadrant 3. All right. For the second one, sine is less than 0. Tangent theta is greater than 0. All right. So sine is less than 0 in quadrant 3 and quadrant 4. That's beneath the x-axis. Tangent is greater than 0 is positive in quadrant 1 and quadrant 3. When x and y are both positive, and x and y are both negative. The only overlap is quadrant 3. All right, so that answers that question. We already did this. We've already kind of done that. This is trivial. This shouldn't be too bad, but just in case we have any issues with it, because these are easy points, I don't want you to lose. I have negative 3 pi over 2, and I want to convert from radians to degrees. So multiply by 180 over pi. If I'm going 2 degrees, 180 is on top. If I'm going 2 radians, pi is on top. Okay, but I'm going 2 degrees, so 180 is on top. The pi's automatically cancel. Now, to be honest, and I hate to tell you this, but I'll tell you, to be honest, once you cancel out your pi's, you can say negative 3 over 2 times 180 in your calculator to get the answers. Okay, I'm not going to use a calculator for this because I'm kind of stubborn like that. Negative 3 times 9 degrees is negative 270. Negative 11 pi over 6. Again, we're going to degrees, so multiply by 180 over pi. I mean, I already know what this one is, though, but we'll work it out. The pi's automatically cancel. First thing, 180 divided by 6 is 30, and negative 11 times 30 is negative 330 degrees. All of this comes from knowing the unit circle. I'll do this probably, even though I'll do it. Yes, you can have your unit circle on your formula sheet. Remember, I'm not policing that. You know, I mean, if you don't have early access to the test, whatever you have on the formula sheet is whatever you want. I don't really care about it. You don't have to get personal. I don't care. Put whatever you want to it. Exact values. Cosine of 7 pi over 3. If you do the coterminal angle for this, 7 pi over 3, we did this problem earlier, I think, and it's the same thing as cosine of pi over 3. Because if I take away 6 pi over 3, which is a full rotation, it's the same thing as 2 pi. I'm just left with pi over 3. 7 minus 6 is 1. So you're welcome so much. And cosine of pi over 3, we already know is 1/2. Unit circle. Cosecant of negative 390 degrees. Right, if we add 360 to this, if I add 360, I end up with negative 30 degrees. If I add 360 again, because I'm still not where I want to be, I end up with 330 degrees. So this is the same thing as cosecant of 330 degrees. Now, boom. All right, so The sine of 330 degrees is equal to negative 1/2. 30. Yeah. All right. So that means that the cosecant is negative 2 over 1. Because to get from cosecant to sine, I take the reciprocal of the fraction. Oh, by the way, anybody who has any emails to me, um, I will respond to those right after this. Right after this session. All right, lots of type problems, which is bad for me. If you have any questions, feel free to jump in because a lot of these problems look the same. Okay, we are right. Same thing. Yeah, we'll do this one. You notice a lot of these problems look. I keep saying these problems look the same. That's because a lot of these problems look the same. Okay, hold on. Make sure this. Refresh that. There we go. Okay. Sorry about that. It looks like we were freezing up a little bit. All right, so we have a triangle here. Boom, boom. That's the right angle. Man, I don't know what's going on. It's like my drawing skills are improved. That's B, S, C, that's 58 degrees right there. All right, and the goal is for us to solve for this triangle. So that's big B, that's little c and little b. Okay. So the first thing we want to solve for is big B because it's going to be a whole number. This is 90, that's 58. 90 plus 58 is, wait a minute, 90 plus, that's 148. All right, if I subtract that from 180, I get big B equal to 32 degrees. All right, we automatically know that. You always go for your angles first if you can. Another rule, for this is to use what you're given if at all possible. Because if I miscalculate that and put 22, and then I start doing answers, and all my answers are based upon a mistake that I made. So use what's given if you can. So for this angle right here, and this is the angle that we're using, which was 58. From 58, this side is opposite, this side is little b is adjacent, and C is the hypotenuse. So from 58, I want to find little b. So I'm going to do tangent. So tangent of 58 degrees is equal to 17 over little b. And since we're here, that's opposite, that's hypotenuse. Sine of 58 degrees is equal to 17 over h. All right. You have to do a little bit of algebra. Multiply both sides by b, and I get b not sine. B tangent of 58 degrees is equal to 17. And then divide by tangent of 58 degrees. So I get B is equal to 17 over tangent of 58 degrees. That's a calculator problem. 17 over tangent of 58. I get 10 point, round to the 10th, 62. So 10.6 is B. Although you're focused on the process here, the answer here, if you look at the process, then you notice a pattern. You've done problems like this. If the variable's on the bottom of this, then you can just switch the variable in the trig part, and you're good. So H is equal to 17 over sine of 58 degrees. All right, if I put in my calculator, sine of 58 degrees, I end up with my hypotenuse equal, rounded to the nearest 10th, 20.0. And that's that. And we've solved for the triangle. Very good. Let's see if we have anything else here of interest. Two good problems. This is number 14. So we'll do 50. All right, so for number 50. All right, we'll find the reference angle for 2 power 9. Okay, this problem is kind of a cheat problem because the reference angle for this is 2 power 9. I know that because it's acute. It's acute, and this is in quadrant 1. How do I know that? If I draw, so determine I can draw straight lines, just circle that close problem. All right, if this is 0, if my denominator is 9, this is pi, which is 9 pi over 9. Okay, you can't put fractions you can't put decimals in a fraction. Right, but if you could, this would be 4.5 pi over 9. Okay, again, you can't do that. This is the same thing as pi over 2. So in other words, if this rotation is pi, this is half. So this is 9 pi over 9. Half of 9 pi over 9, which is 4.5. Again, you can't do this, but I'm doing this to prove a point. 2 is less than 4.5, which means it's over here. It's in quadrant 1. If your angle is in quadrant 1, it's your reference. The reference angle is itself. All right, so that is a good, probably that's an important. All right. All right, for this problem, I'm gonna sketch a graph. All right, so we'll go. That looks terrible. All right, and this is 2 pi. This is 4 pi. This is 6 pi. This is 8 pi. That's opposite 0. This is negative 2 pi. This is negative 4 pi. This is negative 6 pi. Right there. All right. So they want us to describe the graph below. So first, this is 1. This is 3 over 2. This is negative 1, negative 3 over 2. All right. So first, this starts at 0, where our function is going to be 1 equal. Let me move this so you can actually see it. That's not right. There we go. That's better. It's not better. That's better. Okay. First, this graph starts at 0. That means that this is the sine. Cosine starts at a maximum or minimum. All right. This sine normally goes up first. This goes down. There's a negative there. This goes up to 3/2. This goes down to negative 3/2. So 3/2 is the amplitude. X there. It's not shifted up, so there's nothing after the x. So we have to do the period. A full cycle, all the way down, all the way up, is 8 pi. So my period is equal to 2 pi over b. And 2 pi over b is equal to 8 pi in this case. All right. So we have to do a little math. 2 pi over b is equal to 8 pi. We are going to multiply both sides by b to get it out of the denominator. So 2 pi is equal to 8 pi over b. I'm sorry, 8 pi times b. We're divide by 8 pi because we want the b by itself. I'm out of space. Yeah. So 2 pi over 8 pi is equal to b. Pi's cancel, and 2 over 8 is 1 over 4. So b is equal to 1/4. So for this function, y is equal to negative 3/2 sine of 1/4 x. This is a problem straight out of the this is a problem out of study. In previous problem, the triangle was not a right triangle. How do we do it? If, as far as I know, and I need to double check it, in that instance, we would use the law of sines or the law of cosines in order to solve the triangle. Further, there's an area formula for when it's not a right triangle. But generally, especially in this section, for this test, we're not dealing with non-right triangles. It's a really good question. All right. So we are right at 10 o'clock. And a lot of these problems look the exact same. So at this point in time, I will take any questions. And if there are no questions, then we'll go ahead and shut this down so that I can respond to emails and so you can get some rest. Yes, the formula sheet, front and back, half by 11. Regular, no paper or printer paper. Even it's fine. You're both welcome. I'm glad to help. You're welcome. You as well. Thank you. You too. All right. If you have any questions after this, feel free to email me. But I'm going to go ahead and end this now. Have a good evening.